Thanks, Gavin, and thanks for all of you joining us online today. I'd like to take just a minute to introduce myself and my co-presenters. I'm Jamie Curtin, and I'm the Global Sales Manager for Hexagon Content Solutions. And I've been in the mapping industry for over 30 years, delivering innovative solutions to government, telecommunications, and utility organizations around the world. In my current role, I have a responsibility for airborne sensors and Hexagon content sales. Brad, could you introduce yourself?
Absolutely. Thank you, Jamie. This is Brad Adams. It's very good to be with you all today. I am the mobile mapping sales manager, and I have 25 years of bringing geospatial solutions to infrastructure. And today we're going to look at a wide variety of reality capture platforms.
And hello, everyone. I'm Clint Smith. I'm a product manager like at Geosystems in Switzerland. I'm happy to be a part of this. I can't say that I have 25 and 30 years experience. It doesn't show, but I have a number of years of experience, a good knowledge of this, and I'm very pleased to be part of this event today. Back to you, Jamie.
Yeah. Thanks, Clint. As background, Hexagon is a global leader in sensor and software solutions with core capabilities in reality capture, positioning intelligence, 3D simulation, location intelligent mapping technologies. Hexagon is setting a new standard in the industry with our ability to capture anything and everything in 2D and 3D. Using customer success stories and technology examples, this session will discuss the advantages of mapping above the ground, on the ground, and below the ground to capture, visualize, measure, and plan smart cities of the future. So let's start with top down from aerial mapping. So Hexagon, our airborne sensor solutions are used around the globe today. We break these solutions into three groups. Real City, this incorporates Hexagon City Mapper sensor. City Mapper sensor is a hybrid sensor. It incorporates 5 150 megapixel cameras, one positioned for nadir, straight down, the other 4 at 45-degree oblique angles, in the 4 primary cardinal directions. And then incorporated in the center is also a 2 megahertz LiDAR. For real world, these are our large format digital sensors. The DMC3, 25,000 pixels cross track. And then we get into real terrain. Real terrain is our LiDAR suite of sensors. Terrain Mapper and ALS are traditional linear mode sensors, while SPL, single photon LiDAR, is the newest kid on the block. And to think about single photon LiDAR, think about in traditional linear mode sensors, you're firing a light beam at the ground. When you think about SPL, think about firing that light beam into a 10 by 10 grid to create 100 beamlets. Those beamlets act in the same characteristics of the original light beam, just more data to track. So it captures an awful lot of data very rapidly. It's built for high speed, fast collections of very large areas. So if you think of SPL, think of that as state-based or country-based programs, whereas a terrain mapper and ALS 80 are geared more towards county-based programs, with a city mapper again being in the urban areas. There's a complete set of software called HexMap. That all these sensors, the workflows are complete for processing all the data through the platform, so that we have complete control over the acquisition and the processing of the data. Now I'd like to turn just a little bit towards our content program. And if I can get my cursor to work. I cannot get my video to play. There we go. So let me run this quick video demonstrating Hexagon content imagery. The imagery is a subscription-based content as a service platform. Streaming is provided either through WMS or WMTS. It's a cloud-based platform that leverages Amazon Web Services. And in 2020, we are starting the 3rd refresh cycle of the platform. Traditionally, the wide area coverage was captured at 30 centimeter. So this would be the state coverage or a county coverage or a country coverage in Europe. And in the urban areas, we had 15 centimeter. But starting in 2020, we will be migrating to 15 centimeter coverage nationwide. So I'd also like to show you a second quick video for urban areas. This is using our City Mapper sensor. City Mapper, as I said, offers a unique data stack. It's the co-collection of LiDAR along with nadir and oblique imagery at the same time. And in this video, that data collected from City Mapper, and you're actually looking at Rotterdam, the city of Rotterdam, was processed through using our HexMap software. And as John alluded to earlier, the visualization of this is a new package coming forward from Hexagon called Hexagon Digital Reality. So what is content? The content program is Hexagon's delivery platform for geospatial data. It's a market-driven program. It's high precision, high accuracy product. All data is captured using Hexagon sensors, processed using Hexagon software to a well-defined photogrammetric specification. The result is the accuracy of the data, which sets us apart from all others. From providing 3D models to high definition layers, we put the highest quality airborne imagery at your fingertips. Hexagon content provides complete coverage of the US and Western Europe. As I said, we're starting our third refresh in the United States, and this year we're starting our second refresh in Europe. We have over 21 square kilometers of imagery, and the data is continually being refreshed. The current refresh cycle for the Hexagon content program is a 3-year cycle. So every 3 years, we do a complete refresh of both the US and the European coverage. In the next few slides, I'd like to show you a few use cases of the Hexagon content. Specific to 5G network build-out, we have a number of customers and clients that are using the DSM, so it's one of the intermediary products that's collected as part of the program, for identifying objects and clutter height to assist with line of sight mapping for 5G network installations and build-outs. The core product is our imagery, and in this case, talk about its use in conflation. In the past, many utilities maintained their own vector land bases. Leveraging Hexagon content, utilities can conflate their GIS vector data to overlay on Hexagon imagery, eliminating the need for future vector land base updates. As the imagery is refreshed and released to the platform, subscribing customers have access to the updated land base information as soon as it becomes available. Further, if used by multiple utility or governmental agencies, Hexagon content offers a consistent and common platform that can drive workflow efficiencies and collaboration, such as joint utility road opening coordination, traffic planning, and permitting. In the state of California, Caltrans has been using Hexagon content for the last year. They use the data for everything from worksite planning to federal DOT compliance and road inventory reports. Number of states subscribe to the program as well. The state of North Dakota, they have a 3-year subscription to Hexagon content, and the state leverages the Hexagon 4-band imagery for wetland mapping, pervious and impervious surface analysis, and other environmental analysis and research programs. Now that we've gone through aerial mapping, I'll turn it over to Brad to walk you through ground level mobile mapping. Brad?
Thank you, Jamie. I am going to start sharing my screen as soon as you pop off. Can everyone see my screen?
Yes.
Perfect. So as Jamie said, I get the opportunity to talk about ground level mobile mapping. And when we talk about it within the asset and reality capture component, most of you know that within Leica, we have a full suite of products that are ground-based reality series static scanners. It includes a scanner that was introduced a year or so ago, a couple of years ago, and the new BLK series scanners. Today, I'm going to focus on three different systems, and I really want to take a different path in this conversation. I want to show the opportunity of all of the data sets working integrated together. So I'm going to look at how can we take point clouds and other data that has been delivered by these three products and bring them into the same environment. So that we're going to start with the new Leica BLK To Go. It is an amazing new product. It is a handheld mobile scanner that includes a LiDAR. It includes the 12 megapixel high resolution camera, and it includes SLAM technology inherent in the product itself. I'm going to show a short video on just how easy it is to collect data with the BLK To Go. It is literally a single button push, and you start walking around and collecting data. This example shows how the LiDAR scanner is actually reaching out and capturing everything that it reflects off of, as well as picking up all of the imagery from the camera and applying that RGB information to the point cloud while it is scanning. The speed is unmatched. As you can see, you dock the BLK To Go, and immediately you're generating your point cloud and your models. For an example, a sample project of 7,000 square feet has been scanned in simply 21 minutes, and then it is processed, cleaned, and exported in 44 minutes. So you can literally do 7,000 square feet in approximately an hour, which is about 107 square feet per minute, which is incredible throughput. Moving on to more of an asset level, roadway type of a product, we have our Pegasus 2 Ultimate. And we've had the Pegasus 2 or the Pegasus mobile mapping system on the market since 2014. And this is the latest rendition of that product. The Pegasus 2 Ultimate has been upgraded with a 360-degree panoramic camera on the top, which provides exceptional imagery with no distortion. You have your standard GNSS, your IMU. We also include the 4 12 megapixel side cameras for additional imagery capture. We also have a removable hard drive, which really moves this mobile mapping system from doing a project level collection to more of an enterprise level collection. We are able to go out and collect hundreds of miles of data in a single drive and then take that hard drive into the office and start processing almost immediately. The next solution we're going to talk about is the human-based mobile mapping system, the Pegasus Backpack. It has essentially the same types of products from the camera and LiDAR perspective. It allows you to run everything off of a very easy to read tablet. And probably the most important point of that is, from a safety perspective, once you initiate your mission and once you start collecting data, you don't have to watch your tablet. You don't have to be focused on anything other than your terrain, because you certainly don't want to be taking your eyes off in an active construction site. And the really interesting part about both of these systems is they work in exactly the same software. So they both work inside of the Pegasus Manager. And I want to show an example of an integrated project that uses both the vehicle mounted system and the backpack system. The blue line that you saw is the trajectory for the vehicle mounted system. The red line is the trajectory for the backpack system. So we have used each of these systems to collect a construction site that is in north of Las Vegas, and we see here the RGB infused point cloud. And please notice the level of detail that you're able to get from the transmission line. The ability to monitor all of your barriers, to have all of the stockpile information, to see any of the restrictions that you have in this construction, as well as all of the assets that are on the roadway as you are collecting it. But then to be able to access a live construction site and to mobilize within that construction site and pick up the same level of data that you were able to do with the vehicle mounted system, and bring that point cloud and those images together in a single format, in a single product, and use your Pegasus manager to be able to view both the backpack data and the vehicle mounted data. And without any secondary control, only using a base station that was available on the job site, we post-processed both of these point clouds, and we see the blue is the vehicle mounted data, and the red is the backpack presented data. And the ability for those 2 point clouds to lay seamlessly on top of one another without a huge investment in ground control and a huge investment in setting secondary control. This is simply from using the base station on site. You're able to capture exactly the data that you need, bring it into the same environment, and then produce an exquisite deliverable that does not minimize the production of the construction site at all, and it also captures comprehensively the entire data. In this area of the video, we're going to have several cross sections that just show how close the data is. You can see the bottom 2 frames, which is your profile and cross section view, showing that the backpack and the vehicle mounted system are laying one on top of the other. And I wanted to end with bringing a number of different products together in Jetstream, in the software Jetstream. I chose the whiskey distillery primarily because, as we know, drinking has gone up substantially in the last 6 weeks. And why else would we want to think about bringing all our data together unless we're using it for a distillery? But in this example, we're going to combine data from an Abotics UAS, the ProScan mobile mapping, or the ProScan mobile scanner, the Pegasus 2 Ultimate, a traditional P50, and the RTC 360, all into a single profile and a data set that allows us to use exactly the tools that we need in the areas where we need them for the deliverables that are important for your individual client. So we start with driving the outside of the roadway with the Pegasus 2 Ultimate, and then we start scanning shadowed areas with your P50. We use the RTC 360 to capture additional information. And then, of course, you get your overall full aerial view by using your drone. All of this comes into Jetstream, and we are able to produce economically a full comprehensive point cloud in the Cyclone software, and be able to present exactly the accuracy and precision necessary for the different applications that you need. And this is really important. As we've discussed, the quality versus cost is always one of the most important questions that we have. And when you're able to minimize your acquisition costs and use the appropriate hardware to give you the data you need, while also combining that into a single deliverable, allows you to really take advantage of the quality versus cost scenario. And with that, I'm going to turn it over to my friend Clint and let him talk about everything that is below ground.
Thank you, Brad, for that cool information. I hope you can see my screen. I'm not sure if you're seeing it now. Are you able to see the screen?
Yes, we are.
Good.
No.
I'm excited to continue on with the rest of the story.
No,
here because
I'm sorry, Clinton. We're not seeing your screen.
well, then what'd you say that for?
You know, it was my screen all along.
Now you should see it.
Yes.
So happy to continue the story. Thanks, Brad, for the lead off here. We have exciting things here to show you today, and I want to continue the rest of the picture here with what we can do with detection. As Brad and Jamie mentioned to you already, we have covered some of the above ground and on the ground solutions that you can use for mapping and what you're doing with this information, combining it together. And then I'd like to go a little bit further and say, hey, now how do we combine it with what's under the ground, what's below the ground? And it's not that it's out of sight, but it shouldn't be out of mind. So this is a very important part of the picture, and the tools that I want to show you today help bring that picture to all three parts. So one of the tools I want to mention here is also we have a stream up that's going to be doing some mapping, continuing down the road, getting the underground picture, but it's going to help us tie into what we want to call a smart city, to where we're using this information now that we've collected from above ground, on the ground, and below ground to help us with cities, with the development of cities. And as they go forward and continue to grow, we need to have this information. So it's an extremely important part of the puzzle. It's an extremely important part of the picture. And one of the other parts of the picture where detection comes in is the safety of a construction site. So we have two aspects of bringing in this underground mapping to the picture. One, we want to help build and develop and have information for a smart city. And the second is we want to help make a construction site a safer place for crew, for the companies that are working on the site, and to protect the utilities that may be on a site. So I'll give you a couple examples when we go forward here. When we talk about a smart city, everybody wants to know, okay, what is a smart city? We have a lot of information about it. You can look on the internet and find a lot of definitions out there. But essentially, it's a city that's basically using the information that Brad and Jamie gave to you and combining it with other information that they have maybe about their city that helps them grow as a city and make developments in that city, and at the same time protects the citizens of that city. So when we talk about mapping underground and bringing that area to light, to the surface, we can combine that information now and create a smart city. And this little animation series that I have here can show different ideas of where this information is being used. If it's in a rural area, as we develop the streets out, but we're looking for what's under the ground, or if we're on a construction site, you're looking also to see what's in the ground at this site. Or if you're starting maybe a new project, you want to know what's in the ground before you cover it. You collect this information, you put it together, and you're using detection to help you do this. And you can use some of these tools that are mentioned in the next slide here when you have a small, smart system. And the tool one I mentioned is combining both hardware and software to make things work together as a single solution. We have a lot of information when we do these sites. And when we're going through a street or a city to collect the information, to see what's on the ground, developing a map, we collect a lot of information. And we made a lot of improvements here. And one of the ways you need to improve is to use this data more efficiently, more smoothly, and easier for the operator. And Brad mentioned to this before, you can collect a lot of information and process it in a short amount of time. Same thing here. So when you look at this vehicle on the left here, this new version of a radar driving down the street, collecting information, generating an underground map, you can combine it now with some very good software to combine both worlds, all worlds together from above, where you just went over, maybe with information from Jamie, down to the ground level, and then below, and help this develop your project. And this is done with the right tools, this is done with the right hardware, this is done with the right software to help make this picture more complete. And I mentioned software, I mentioned it a couple times. Software is extremely important, and it will play an important part of the development of our future. It will play a part as we develop smart cities. It'll play a part as we work with this information on our construction sites. Here's a nice example. Here on the left side, you see what was done before, or still done today in many cases, where you have a radargram with information from the GPR collected. Not everybody can read this information, obviously, and it takes sometimes an expert years of training to understand what's there in this picture, what's there underground. And I'm not saying it's old school, it's outdated, they're still using this today. But I'm saying the construction sites have changed such that we need to have software do some of the thinking for us, and we need to offer an alternative to do that. And this is one of the things that we have done with this package here. This is using the DSX and the DXplorer software to do the thinking and do the crunching of the data for us. It's becoming now the expert for us so that the user doesn't have to think about it, but they can generate the results they want right away. And basically, they're doing this all on site. And within a matter of minutes, they can get information like a 3D diagram to use and see what utilities are below the ground. Now, when you combine this information, you have a master amount of data that you can use. And if you look at the left, you have a left, okay, I have to learn how to interpret this diagram. But with the software, we can make it clean and simple and easy for a user to interpret. And it's a much cleaner picture now when we're using this software in this way. I mentioned that we wanted to use it for smart cities, and I've shown you some examples of what we did with that information on the smart city side. Development of rural areas, or using it to go down and map a busy street to get a map underneath or create a project. But it's also important to understand that we can use this information to improve the safety of a construction site. And I'll give you an example of that with this next animation. Here we are using a DSX and the DXplorer software to get information that we can't see underground and to develop a map. So if we run our program through here and we get this information, like this clean utility or asset shown on the ground, we can transfer that information to the operator of the equipment, who then uses that information right away to have avoidance zones to stay away from the utilities and the assets that are in the ground, thus improving the safety of the site. It's better for the developer, it's better for the city, it's better for the people on the site, because now we have a safer place for them to operate and for them to work. And these are the places where you can use detection in these applications. And we're taking now, when we combine it all together, we have a complete portfolio of mapping from above the ground, from on the ground, and below the ground. When we had Jamie talk to us about the aerial view of it, we had Brad talk to us about what's on the ground, we start combining this information together. We have now a complete picture of the whole process. And this is something that Hexagon can do. This is something that Hexagon does with all three areas. And we're the only ones that can do that right now when we have this information at our fingertips. So it's fun to be a part of this. It's fun to share this information with you, because I think it's something that you can use to make a smart city. I think it's something that you can use to help develop a safe construction site and protect those assets and it's going to be the way of the future. This is where we're going, and this is what we want to be a part of. This kind of development helps us to grow. And with that, I'd like to open it up to some questions. I'll turn this back over to Gavin to take your questions. I hope you've had a nice, interesting presentation and you had a good day today. And I turn this back over to you, Gavin, for taking the questions.
Okay, well, yeah, thank you, Clint and Brad and Jamie. So that's the three aspects: the air, the ground, and under the ground. So the only questions I got, people were asking a little bit more about GPR. You know, I guess a lot of us have seen or, you know, familiar with the old school GPR that looked like a sonogram, you know, the single sensor. The way you were talking about the 3D, and I've used one, so, but I'm not going to talk about it, is these sets of arrays of the sensors so that it's looking at an area from, you know, across a wide unit, and that it's able to look at those, correlate them, and kind of put the slices in place to delineate pipes. Maybe you could talk a little bit about that.
Well, there's depends on the technology. The Stream Up uses a set of arrays, more of a matrix set of arrays, so it's getting a three-dimensional picture as it passes over with basically a single pass or along a straight line pass. So it picks up both perpendicular or pipes that may be perpendicular to each other as they go over those arrays or those utilities. The DSX that I mentioned in the presentation uses a different set of GPR where you need to make the matrix like the grid that was shown on the display there. But when you overlap those two grids 90 degrees to each other, then you develop a nice 3D image of this area. And it's using the same data that's generated from before, but we have algorithms that generate the diagrams that you saw and gives you the three-dimensional models that the user can use. It's just an easier way, an easier approach for a user to quickly get the information they need more efficiently, and while they're on site, it saves them a lot of time. They don't have to go back and do it again. They can do it right on site.
Okay, and I understand the well, effectiveness and depth can vary a lot depending on soil conditions and moisture.
Yes.
And of course, signal strength limits the FCC. You know. So,
yes, that's true. All plays a factor. It all plays a factor in it.
So generally, is it looking for utilities that are shallower than 10 feet? Well, most utilities typically are, right?
Yeah, most of them generally are. The DSX is going about 6 feet, 6 to 8 feet, 2 meters. So it's about 6 there, and I believe that's about the range on the Stream Up too. I'm not exactly sure on the depth of that, but it's close to that range there, which is covering most of the utilities in that area.
Okay, could you talk about, you know, Brad was talking about combining the data from those multiple. Have you guys got a great example you could tell us about, you know, like a customer that's done a asset mapping in a right-of-way using more than one system? I hate to put you on the spot, but
yeah, I'm trying to think if I have one off the cuff of my hand here. I know that we're trying to work with machine control, like the example I showed you there, and some of the people in our department are coming up with solutions to use this data. We are still working on a better, more streamlined solution where we pull all this data in together to use this. But what we're seeing is this is definitely something that we see the trend for, the need for, the call for, and we're finding better ways to do that. So we're still working on getting the ideal workflow in place, and I guess that will change depending on what location we're working with.
okay. Carrie T sent in a question. How are you combining all the various collection systems for mobile mapping into a single project?
Well, the start is with our Pegasus Manager overall software. And within Pegasus Manager, that allows us to do all of the control and all of the processing necessary for any of our mobile mapping data delivery hardware. From there, we are able to export into any of the traditional LiDAR point cloud types of file formats, whether it's LAS, of course, or E57. And then we also have the opportunity to leverage CloudWorks and Jetstream that will take not only the mobile mapping data, but will include any of the other static scanners that we use to create a comprehensive point cloud and deliverable based on all of the data collected, regardless of what the input source was.
Okay, so pretty agnostic on the outputs, and actually you could take in data from other. It wouldn't matter what the platform was as long as it was one of those standard. That's going to be key, because you could have a jurisdiction where different departments of a city or state got different equipment, and they're trying to match inventory. So that's going to be key.
That's absolutely. Infusing that data with all existing data sources, infusing it with as Jamie and Clint talked about, the data that's generated from above and the data generating from below. We want to have access to mine that data repeatedly for the value that it presents.
Okie doke. Now, Carrie's got a big picture question. So this is, think out of the scanned box a little bit, or image box or whatever, but where do you see the future of utility detection going? I know that's a nebulous subject, but
Yeah, no, from the detection side, I see we have a vast future ahead of us, because I think that we're going to start using more and more of the technology, artificial intelligence technology, to help us do better locates, to do better information on that. But I think what we see then is use of software, then combining that information that we've collected from the detector and moving it in a seamless way to the user, so that they can pull this information that we collect from Brad's instruments or the ones that Jamie presented. And right now we have to do a little bit of work, like I mentioned to you, for this, but I see this as being a major part of any kind of construction project, any kind of workflow where we have detection playing a key role in that. And this is one of the reasons why we're trying to align everything up to pull this information in, because it will be part of the future. It will be using the right software to help the workflow and get the results that we need.
okay, cool. Well, if there's any closing thoughts from you guys, we don't have any more questions, and I don't have any either. I've attended many presentations from you guys in the past. So I'm caught up on that. Anyhow, well, I want to thank the three of you for tag teaming on this. It was great. Covered all those covered those three main bases.
Pleasure.
So,
Thanks, Gavin.
Thank you, Gavin.